I asked you a question actually, what are the groups actually the malicious software belong to? What are the means you classify the malicious software? Remember, we are not bringing something new. We are just having the detail in deep related to the computer programs. The malicious software, at the end of the day, they are computer programs. They are software. But since they are doing analytical behaviors and they are having actually malicious payload to execute, they are classified as malicious computer programs or malicious software or viruses and worms and trojans. So in all cases, they are having a payload to execute, and the payload is having a malicious behavior. Based on the payload, we classify them actually according to what we saw earlier in an early aid in this course, worms or viruses or trojans. But at the end of the day, a payload with a malicious intent. Malicious intent. Here. Groups, worms, trojans, and viruses. Great. Let's continue from where we stopped in this DOS study. Let me start from one of the very famous DOS scenarios, and we keep going on. The scenario of the ping of death, actually, which is the very famous DOS attack or DOS technique or DOS implementation scenario. Is persistent, successful, and very exposed. What does it mean? It means actually if we try to implement it with a very high rate, we will succeed to do it. Even upon a very successful, secure framework, the ping of death will be actually having a high rate of success. It is very exposed. It's not hidden. It's not as obscure or obfuscated. No. It is exposed. And with its exposure, still it has a high rate of success. Why? Because the ICMP protocol and the ping probing technique, it is a technical approach that has to be actually active and validated for usage across platforms, upon and across platforms. We cannot deny the use of the ping or the ICMP package in general, in abstract. Thus, here, the high rate of success whenever we talk about the ping of death as a DOS attack, it comes from here, from this scenario. It is not because it's very hard to detect or to capture or to block. No, completely not. It's very exposed. Yet, because it is a technical approach that has to be actually valid and available for use for different purposes. Probe actually destination is one of the network capabilities that the technicians and the specialists and administrators has to have. It's a weapon to troubleshoot and to fix issues. At the same time, it is used for generating such a DOS attack. I hope it's clear at this point, in this regard. And since it is not actually, it is not to be blocked and it is exposed, there is actually a trust that the doer will be actually captured. Whenever we do a ping of death, the doer, the source of the attack, will be exposed to the destination. So the technical staff or the administrators or security specialists, they would allow this ping of death to happen by allowing some, let's say, weak points against this ping of by at least not blocking it completely. But they trust also at the same time that if any tries to do such DOS attack using the ping of death, he will be immediately caught. Because ping of death is not to be happening from an external environment. Whenever we talk, as per the graph we saw in front of us now, network, for example, number one is going, a member from this network, one computer is going to do an attack, for example, on a computer from a network number n. Across what? Across a public network, mainly we talk the internet. this won't be successful. Won't be successful because the ping and the probing from external source completely is forbidden unless we are talking about an ISP service provider, internet service provider. If we talk about service provider, no, the probing from external environment is allowed. But for example, we take the example of the University of Nizwa. We cannot probe computers from outside unless we are completely authenticated. It's not allowed. For example, this network here, this one on bottom here, bottom right, it is the network, University of Nizwa network, or campus network, for example. And this is actually, it is the, for example, any attack at home, for example, in Salalah, Dhafar. Anybody here is trying to attack a computer here inside the University of Nizwa using the ping of that. No, he will be blocked completely. He will be blocked from the first entry, from the perimeter. Why? Because probing a computer from external environment completely is blocked. It's forbidden. It's not allowed. So where we see this ping of death successful, I was about saying now, actually, I was only now just in a while saying that the ping of death is having a high rate of success usually and continuously. How? And now I'm saying it's blocked because the ping of death, it would be actually successful and having a high rate of success if it is happening from the same framework. From the same here, for example, our University of Israel campus network, a member from the same network tries to do a ping of death on another computer from the same network. Thus, here we talk about a high rate of success. But from an external computer, fully denied. Fully denied. The ping will not come in. Never. We can allow. Yes, we can allow. But default settings, fully denied. Means it will fail immediately. And because of this view, if any from inside the network tries to ping, doing a ping of death, any other computer, he will be caught, he will be recognized. His ID actually is recognized. So computer number 1 is trying to do a ping of death on computer number N. Immediately, the computer number 1 will be recognized. He is the one who did or who launched this ping of death. So they will know the attack and they will block him and they will do the necessary. Because of this, it is still trusted and kept working. Yes, tell me.
في اللاب نفتح كاميرا.
Who is the speaker? Rayan.
ريان.
Yeah, أكيد Rayan. Are you with me in the explanation, Rayan?
Yes, mister.
Yes, sure, absolutely. سأعطيكم وقت ما راح. I will not take a long time, so I'll give you time. Just follow with me. Let me finish the explanation and I'll give you time. Don't worry. I'll finish early. Be with me. Okay, let's just go a little bit further. Yeah, actually, the protocol responsible for managing the ping and the other, let's say, network tools like the NetStat and so on, we talk about the ICMP, the Internet Control Protocol, yes, Control Message Protocol here. It's one of the very famous communication control protocols that actually it has to be, I may say it's the umbrella, the header, the top, the cover, under which the ping is running. The ping does not have any port, but this protocol do have a port. So as a service, the ping, it is completely related to this ICMP. The ping actually, it would send a size, the memory size to be allocated. Mainly the size of the ping, the probe is 128 bytes, but it is to be customized. Whenever we talk about the example we saw in the lab actually for the ping of death, it was actually 65,500 bytes. So it can be customized, that's the memory space. Even it's empty, but it would allocate that space. It will tell the computer, hey, allocate me this space. Is it available with you? The computer will allocate that. If it is very big, so the computer will be completely collapsed. It will not have enough space for millions and trillions of ping requests. We also discussed the context of the IP address actually used for the attack. For example, it has to be spoofed in somehow. What does it mean? Means actually when we said when I was discussing that a computer from an internal network would actually do a ping of death to another computer from the same network, it will be completely captured and recognized. Because of this, also there is a technique, there is an approach via which administrators deny specific computers, specific IDs, specific users from launching the ping probes. What does it mean? For example, we have a network, we have n computers. Computer number 1, number 2, they are denied. They cannot launch a ping request. But computer number 3 and 4, they can launch ping requests. Okay, here there is a discrimination. Yeah, because of the service only. It's not a discrimination because of yes, we allow or don't allow. No, it's a service to be, it's a role to be given. Because of this role, an attacker, for example, using these computers, he will not be able to launch the ping of death. What is the solution? What he has to do? Is it actually the end of the day and he has to go home? He cannot do anything? No. We talk about the ID spoofing. We talk about the ID spoofing. The ID main is the IP address. That's the unique ID actually we still commit to be the identifier of the device within the network. To spoof it with what? With an ID that is already recognized by the service provider as a one to be trusted and to have the service active of pinging. So here actually for this reason we talk about the address spoofing, source address spoofing. And this actually it has consequences and drawbacks, because if we talk about an address spoofing, we might actually spoof an address more than one time, and we might keep spoofing the address for n times. We talk about a recursive call to spoof the ID for a reason or another, and this can cause a congestion of requests due to requests to, or let's say, the big number of requests and things like that. We'll talk this backscatters actually, where we use the backscatters. We talk about it just what in a while. Yes. Here actually it's a scenario via which we send, or actually we share the routes for the unused IP address in order to allow, or to, let's say, to control the attacks once they are actually happening. Exactly like the scenario we're talking here, we are subdividing and identifying users by ID, and accordingly we classify sorry, so accordingly there will be actually discrimination somehow. Groups are allowed, groups are not, groups are given the service, groups are not, and so on. Based on this, actually you are monitoring, you're doing a monitoring activity on the routes via which attacks might happen, and the attacks they have to be actually recognized. Either we talk about the spoofing here, like here, any communication from such channel or path or circuit, it has to be monitored, or any service, for example, the ping from a given route has to be monitored. So services or IDs, they have to be monitored upon given paths or routes. This is the context of the backscattering traffic. It's a sort of, when we say actually it's a monitoring, to monitor, it's a sort of a honeypot to create. What does it mean actually? If we find an attack, a ping of that attack coming from a given path, given root, given circuit, it would be immediately captured. So this is a honeypot. We identified what is it, a honeypot, and it has to be clear in your head. Okay, the very famous actually DOS attack is the SYN-based actually SYN-based attack. Using the SYN message, actually, a SYN communication would flood, an attacker would flood a service provider. Why? Because every communication starts with a 3-handshake process, and then after the communication and the sharing of resource would start. A client would send the data or receive the data from a service provider, so he has to do a 3-handshake process first, then after the communication continues. What is the 3-handshake process? It is to declare that, hey, are you alive? This service provider has to reply, yes, I'm alive. And then after this one declares, okay, I'm sending you data now. To ask, are you alive? It is a SYN message to be sent. It's a problem. This service provider has to reply with, yes, I'm alive, replying with a synchronization acknowledgement, SYN-EC. Synchronization acknowledgement, I'm alive. Then after actually this one, he will confirm, yes, okay, I'm sending you data by sending an acknowledgement message. Hey, okay, I'm coming. Synchronization acknowledgement, SYN-EC. This is the 3-handshake. Okay, we keep sending SYN. Actually, if we send trillions and trillions, see the number, trillion synchronization requests to a service provider. This service provider has to reply, so at that time, it's by must. He has to reply with a SYN-EC. For each SYN he receives. So whenever the number increases in synchronization, this one will be actually flooded with requests that has to be replied. Thus, we talk about the SYN flood, and actually here, actually the SYN spoofing also, we'll talk about it just in a while. And because of this, let's say heavy load requests of synchronization, a DOS attack would happen. For what it concerns the spoofing here, for what it concerns the spoofing, the SYN spoofing, it is a scenario via which we see a SYN coming from a destination, from a source, sorry, and the SYN acknowledgement is going to a different destination. So this is the one who sent the request for the synchronization. By default, he has to be the one to receive the SYN acknowledgement, Now, if the synchronization ID has been spoofed, so the SYN acknowledgement will be sent to the spoofed ID, which is the one specified here, which is the one specified in this attack, in this request. So it would be actually a third computer, a third device. Computer number one sends the SYN, service provider receives the SYN, he has to reply with the SYN-EC. The ID sent in the SYN request is spoofed. So the SYN acknowledgement it would be sent to the ID represented here, which is spoofed already. In this case, the third computer, the third device. Here it comes. We talk about SYN spoofing here, and this is not the end of the DOS attack. Here only we are talking about falsifying the ID. Exactly what I was explaining right now regarding the SYN spoofing. Yes, and now because of what I explained, you have the clear understanding of what is the SYN spoof and the SYN flood. Okay, the ICMP and the context of the SYN attack and SYN spoofing and SYN flooding, it is a scenario via which we identify a process over the connection-based networks, ICMP protocol. But for the scenario where we are connected in a wireless network, there is no SYN attack, there is no SYN flooding, there is no SYN spoofing. Why? Because there is no three handshake to be happening in a wireless network, in a wireless connected devices, in a computer network where the wireless signal is the media via which data is shared. Wireless networks do not have the concern of the SYN spoofing and SYN flooding. Why? Because the three handshake SYN EC is not available in the wireless network. The UDP protocol, user datagram protocol, is one of the protocols that actually it belongs to the layer number 4 transport over the OSI model. And this protocol do not enhance, it enhances actually the wireless communication processes, but it does not support the three handshake process. So, okay, we are very fine here. We are very secure in such environment. We are very secure from what we call it SYN acknowledgement and acknowledgement processes. It's not a security here, but we are deprived from that. But we are secured from the SYN spoof and the SYN flooding and the NAFTA, the sort of the SYN-based DOS attacks. SYN-based DOS attacks. Any questions, please, in this level?
No, Mr.
Okay, I'll stop at this level to give you a free time actually to prepare for your lab. I'll take the attendance first of all only.